everybody. In the language of the land that we meet upon today, Womenjika, and in the language of my ancestors, Warrami, this morning we meet on Wurundjeri Woiwurrung country, a country that has been cared for over tens of thousands of years by a deeply scientific peoples. Woiwurrung elders have held knowledge of country over generations, passing that knowledge down through story, practice, and law. These knowledges are grounded in scientific practice of careful observation and experimentation, and these findings have been passed down through countless generations. I pay my respect to those elders who have come before and those that lead us now, and I pay my respects to country and the enduring legacy of care that resonates throughout the diverse and distinct Aboriginal and Torres Strait Islander cultures. We are, as a broader society, all facing a common threat in climate change and biodiversity loss. The solutions and mitigations for these problems lie not only in the advancement of science, but in societal change. In her welcome to country that ushers you into Emu Sky, Auntie Joy extends an invitation for all of us to walk together to care for country. And I see science as a critical part in caring for country into the future, and I'm continually amazed by the amazing work by some of my colleagues here at the university. Well, all of my, I'm not going to say some of. Not all of you. All of my colleagues here at the University of Melbourne. My name's Maddie Miller, and I'm a Darug woman and a researcher here looking at different ways of knowing. And this morning we're privileged to hear from two incredible speakers who need no introduction, but I will introduce them anyway. And excuse me, I've sort of paraphrased your incredible bios just a little bit. Moira extends her apologies for not being able to join us this morning. And we have the wonderful Professor Margie Mayfield, the head of the School of Biosciences, in her place. So Professor Margie Mayfield is a plant community ecologist, interested in how changes to the environment impacts plant and insect communities' structure and function. Her work spans theoretical and applied questions about how biological diversity is maintained in general and in responses to local to large-scale environmental changes resulting from climate change, invasive species, urbanisation, agricultural intensification, and restoration. She is joined by Professor Duncan Maskell, Vice-Chancellor of the University of Melbourne. Professor Duncan Maskell became the 20th Vice-Chancellor of the University of Melbourne in 2018, and prior to this, Professor Maskell was a Senior Pro-Vice-Chancellor at the University of Cambridge, responsible for overall planning and resources for the globally recognised institution. In addition to academic and university leadership roles, Professor Maskell has enjoyed an active entrepreneurial career, co-founding 4 biotech companies among his accomplishments, including Arrow Therapeutics. One of his goals as the Vice-Chancellor of the University of Melbourne is to further advance the commercialisation and application of our vast research programs benefiting society and industry. Professor Maskell supports a culture of philanthropy, public education for public education for public good, and a strong international presence to attract and retain the best of the best. He is also fervent in the need to gather rigorous data and communicate clear, factual messages to the public, preventing the perpetuation of misinformation and myths. So, thank you to both our speakers.
All right. Well, I will. Can everybody hear me? Yeah. All right. I will do my best to stand in for Moira. I've had one day warning, so bear with me. So I think just to start, I think we should talk a little bit, and maybe you could start by telling us a little bit about your journey into science.
Okay. So I have always been interested in a lot of things. I guess I'll start there. At school, I was interested in history. I was musicians, everyone knows, et cetera, et cetera. I was also really interested in science, and I was really good at chemistry. And I've never had a career plan. I've never had a plan for my life at all. I've just sort of rolled around and enjoyed life. And but at school, they kind of pushed me into because I was really good at chemistry, pushed me into doing chemistry. And what followed from there was biology, and what followed from there was maths, and that sort of set my life up in a way, randomly in a way. But I kind of really enjoyed science, and I really enjoyed understanding how the world works within that framework. I had a massive decision to make in about 16 or 17 years old about whether to continue to do science or whether to go and be a musician. And I chose science, partly because my mum and dad said, you have a good job as a lab technician if you do science. If you go and become a musician, you'll get long hair. Well, I had a long hair already, but you'll be, you do drugs and you'll just disappear.
Become a hippie.
Whatever. So, I mean, they were right. But I wound up being able to do music on the side, which is great. And I didn't become a lab tech. I got to university, first in family to go to university. Got to Cambridge, which was amazing, etc. And when I got to Cambridge, I did chemistry in the first year, and then started to grapple with Schrodinger's equations, and decided that at that point my mathematical ability was not up to it. So I was already pursuing also at the same time course units in biology, and particularly pathology, because I was always fascinated by disease, really interested in disease, and wound up doing my honours in pathology. I did an honours project on typhoid fever. That really sparked my interest, and then went on to study that, other things for my PhD, and then continued my career working on bacterial infection. And then eventually got fed up with the management in the university, so decided to do something about it, and applied for a couple of jobs like head of school, and then became senior PVC, and then wound up here. Yeah. So now I'm the bloke that everyone's fed up with, which is so it goes.
Yes. So should I tell a little bit about my
journey? Go. And we're supposed to be having a conversation here.
We're supposed to.
Yeah,
I'm
sorry.
not supposed to interview you.
I'll get on message. Sorry.
That's all right.
Well, tell us about your career, Margie?
Thank you, Duncan. I will. So my background is a little bit different, I suppose. My father was a scientist. He started as a physicist. He also figured out he wasn't good enough at math to be a physicist, so he switched to biology, actually. But that said, he didn't talk a lot about being a scientist or an academic as a kid, but I spent a lot of time outside with him. And I think even though he didn't do it explicitly, he taught me how to be a scientist at a very young age. My academic journey, I was actually, well, I still am dyslexic, so I had a lot of trouble with school. I was not identified as a particularly bright, promising student as a young person. But I had that science at home, and that was very important to me. And I actually originally thought I would be an artist. Because I had trouble writing and reading, I had some amazing teachers who encouraged me to paint my essays and things like that. So art very much appealed. And when I was 17, I went to Ecuador with my aunt, and everything changed for me there. I just fell in love with the rainforest, and I fell in love with just the magnificent complexity of a rainforest, and I knew that that's what I wanted to do. And throughout my career, I've actually always felt that art and science have a lot in common, because what I find particularly satisfied about science is the creative element, just problem solving through creativity, which to me, it's not a paintbrush, but it's still a way of using that creative side of your brain. And so I wanted to be an ethnobotanist, but it didn't work out for various uninteresting reasons. But through my education, I became very interested in challenging questions. So I've sort of switched back and forth throughout my career between very applied work and very, very theoretical work. And it sort of depends on the challenges that I'm particularly interested in at the moment. When I was in the US, I actually focused more on applied work, because when I was a PhD student, it was almost a dirty word to say you were an ecologist who worked on anything but pure fundamental ecology. So being a bit of a contrarian, I was like, well, I think I will work on applied questions. And when I moved to Australia, I found the opposite to be true, that there was very little work on understanding the fundamentals of ecology. And so I've largely switched to that here. And in part because coming from the Northern Hemisphere, which is where most of ecology has been done, I got to this amazing country and just looked at the fantastic biological creatures and thought, there's so much to know. How can we not be studying these? And then I'd say I'm at an earlier stage of my career, but similar I got frustrated, started applying for more administrative roles, and so I'm following a similar path later in my career. Yeah. So I guess moving on from here, you're the one who came up with this idea for talking about what the point of science is. So I thought we should.
Did I?
Apparently, that's what my notes tell me.
Extraordinary. You know, I have this, as the Vice Chancellor, I sometimes have a throwaway line, and somebody hears it, picks it up, and runs with it, and then it's become my idea. It's extraordinary.
I think you get a lot of credit for things you wish you didn't.
Yes,
Yeah.
you're right.
So I think it's a good question, though. What is the point of science? Why is it so valuable?
I'm ashamed of the question because it's obvious in some sense. What's the point of anything? You know, I mean, I think you can give some form of deeply philosophical answer, or you can give a practical answer to that question, actually. I think maybe not deeply philosophical, but the thinking answer is around scientific thinking is something that human beings have done for a very long time. Mm-hmm. It may not have been formulated in that sense. Yeah. I mean, the word science really just comes along, I think, in around the 14th century in Europe as a word, derived from Latin, meaning knowledge. And the sort of scientific enlightenment is sort of 16th century Bacon, and then through the 17th century with Newton in the sort of European tradition. But people have been doing science for forever, in a way. Yeah. And you know, we see that in ancient texts. Since being in Australia, I've learned a lot more about how the indigenous people were observing the world in which they lived in a structured way, learning from that. And I was up at Arnhem Land at Garma just a couple of weeks ago, and we went with Dwayne Hamaker, who has just written a book about indigenous astronomy, and we went there and lay down and saw the stars and started talking about it. And I can't remember what it was now, but in the constellation Scorpio, there's one of the stars which, when it reaches that certain pitch in the sky, that's the time of year when the stingrays are coming in to be hunted, you know, sort of thing. And that's a very good, in my opinion, example of scientific thinking. It's taken observations, it's distilled the information, it's been used in a predictive way. Yeah. Kind of, you know, there it is. So there's that, but then I think the practical answer also is related to that, in that applying the scientific method to the universe enables you to understand things in a way that can then be used and can then be predictive. Yep. I think there are other knowledge systems where you can do that to some extent, but the big difference is that in other knowledge systems, I think assumptions that you make are probably never tested. So it's all fine as long as those assumptions pertain. Yeah. But science tests the assumptions, and you know, you have to be rigorous with yourself about slaughtering your own sacred cows on a regular basis, and that keeps you very honest in terms of what really is there and what really matters. I think there are some elements that, like, really down in the sort of, I see Kate there, you know, it's in the mathematical end of sciences, which quite a lot in there. I know I'm on dodgy ground here probably, but quite a lot there is really very solid. Now 1 + 1 does equal 2. I think that's right, but yeah,
solid.
You know, and it's really hard to gainsay that at all. You know, but in some of the biological sciences, as you know, it's quite complicated in a way that you've got to come up with stories to try and explain things that are happening, and testing those stories in a rigorous way can be quite difficult. And more recently, of course, in some areas of science, we've gone back to a sort of pre-Popperian system, where hypothesis testing is quite difficult. Mm-hmm. So with the genomics revolution in my area, in bacteria, hypothesis-free research is a phrase that's now used quite commonly, in that you just go and gather thousands of samples from whatever thing you're studying, you sequence the lot, and you just see what emerges from the data. This is going back to a very sort of Baconian model of science. Yeah,
we call it fishing.
Yeah, it's called fishing. But it works, actually.
Yeah, it does, and I think it's actually an interesting point that you bring up about, you know, I think even though we've come from different countries and different backgrounds, we both follow the same sort of view that science is coming out of the greats of Greek and Roman philosophy, and we're now at this sort of transition point where we're understanding that there are different Science has been a part of many cultures, and in the Western world, we've had a very narrow view of it. And I think, to some extent, the transition away from the very Western classic hypothesis testing, in my mind, is a bit of a positive move in that it is accepting a different way of thinking about how to do science, and that you don't have to do it necessarily in this specific way. And I wonder about I'm sort of curious about your thoughts about this transition that we're going through, and recognizing that the scientific method is something that's beautiful and pure and an excellent approach to testing questions. The construct around it is very cultural.
Yeah.
And
I think that's right. I think, first of all, I'd like to say that I don't think human beings are really good at setting up false dichotomies. All right, so we don't have to reject the hypothesis testing system if we're going to do this other system. We should do all of it.
Yes.
And apply the right methodology at the right time to the right question.
Yes.
So I think that's really important to keep reminding ourselves of.
I think another one that you bring up is the black and white view of there is a right and a wrong answer, right? I mean, I would say in my career, one reason I studied community ecology, which is like the most complicated. It's all the species interacting all at the same time. And what appeals to me about that is there is no right answer, and that's very clear. But a lot of scientists struggle with that. And I think it's a very important journey that we're going on to realize that something that is different between mathematics and, although I think there's various answers sometimes in mathematics too, but 1 + 1 is pretty solid. But I do think that with our cultural change and our cultural view of science changing, that we are becoming more comfortable as a scientific community with the idea that it's more about when and where the answer is this than what is the only right answer. And I think that's quite an important transition we're going through. My personality is a bit more black and white than that. So I think in many cases there is a right answer. Yep.
Actually. But it depends on the complexity of the question as to how right you can be.
That's right.
So, and also there's another aspect of that, which is that in everyday life, Newtonian physics is right.
Yeah.
Right. So it still describes how the planets go around, and it's all fine.
Yeah.
But actually, we know that it's not right at some other level because Einstein came along and
pointed out
the different. But does that to what extent?
It doesn't negate the rest, right?
Yeah, the Newtonian is a sufficiently good model of the universe to be used most of the time without a problem.
Yes, but I think often our Western view of science has come from a place of seeking the ultimate truth.
Sure.
And there's lots of questions in the natural world that
this is
there's
why we
lots
need
of
to,
answers to.
This is why we need to work hand in glove with philosophers. And I've said before, and I say it again now, I think every single science student should do at least one course in philosophy to understand the underpinnings of the thought process and understand what different epistemologies are and all the rest of it.
Yeah.
I think it's very important to do that.
I agree.
Because, I mean, what is a fact? What is the truth? And how do you define those things?
Although I took a philosophy class and I was very frustrated.
Well,
I'm not a philosophical mind. They spent a long time discussing an author's choice of word, and I was like, I don't think they probably thought about it this hard at all.
No, that's true. They probably didn't. But it is important. You know, what do you mean? Define truth.
That's right.
Oh, yeah.
So I think we could move on a little bit and talk about a different
let's.
aspect of we're getting deep into philosophy here. A big topic in science that comes up in Australia is impact. And it's something I think that scientists and universities as a whole are really are sort of grappling with a sort of societal fascination about impact and a government insistence that research has impact and what that actually means.
Because it's easy for them to understand.
Yeah, except if you ask somebody what is impact,
Exactly.
people have a hard time answering. So I'm wondering about your thoughts on this sort of impact revolution that Australia is going through and the impacts that's having.
I think it's
on
about 20
science.
years after the rest of the world.
Yeah.
Is the first thing to say, sadly.
Yeah.
I'm on the record, and I will die in a ditch on this one. Well, universities are primarily there to be the engines of discovery, and to do the basic research, and to do all the discovery stuff.
Yeah.
Very important message to keep getting out there.
Yeah.
One way, so that's in and of itself enough for me.
Yeah.
But if you want to convince politicians that that's important, you then go the next step, which is to say, all this stuff we're going to translate and have impact. doesn't exist without the discovery end, right?
Yeah.
So that's part of that thinking. Having said that, and I've said this publicly many times before, I do not adhere to the sort of extreme purist view that was around some time ago, that the only science worth doing, the only scientist who's worth his or her existence is somebody who does this high-level basic science, right? I just don't accept that. I think many great scientists that I've met and known in my life, including Nobel Prize winners, understand that their very basic research does have potential applications quite often, not always, but quite often, and they understand that if it does have those applications, that it's actually rather exciting to do that, you know.
Yeah.
Now, application of research is really the area we're talking about, and it's not just science either; it's application of research across the piece in the university.
Yeah, absolutely. Yeah.
I think I would go so far, and I said this as well, that we have a duty to apply our research if we can.
Yeah.
You know, it's part of our social purpose. We're very lucky and privileged to be working in universities where we're free to do what we like, and we get paid reasonably well for doing it. And you know, the payback time is that you should then try and give something back to society.
Yeah.
You know,
Yeah.
so that's where I land. Now, right at the end of that spectrum is commercialisation.
Yeah.
They these discussions usually start with commercialisation as if it's the end point for everything. It's not true.
No.
But again, if you can commercialise something, why not?
Yeah, I think in this country though we've started to equate impact with commercialization.
Well, that's right, and that's
which is not at all the only
not
impact.
at all the
that
only
we can
impact
have.
at all, and it's to do that simplistic equation is detrimental to the overarching, the overall
Yeah.
business of translating research. You know, getting new methodologies for treating patients is the easy, obvious area, which it almost certainly won't be monetizable or commercializable, but it improves practice massively and saves people's lives.
But I think, you know, in fields like
I was
mine,
gonna
in
ask you,
ecology, and
since this is
a
a discussion rather than interview.
conversation, that's right.
I am genuinely interested. You know, where do you lie on all this?
Well, I think, I think something that I grapple with, and I think my colleagues in the similar areas grapple with, is we view what we do as highly impactful, right?
Yeah.
We are studying the natural world to improve our understanding of it so that we can help protect it in the face of enormous challenges, right? But there's no money in it. There's no product. You know, I talked to a company who wanted to patent bee pollination, and I was like, I just don't think you're allowed to do that. That's just that's just nature. But
Well, you could if you invented a widget to do it. Now,
you could, but
patent
they were
widget.
like, can I just choose 3 species and then we can use that all over the world? And I was like, no, no, you can't. So I think it's sometimes a problem that our society is so focused on making money instead of thinking about science as an incredibly valuable tool for advancing our society as well, and advancing the way that we think about the world, right? And to me, I view fundamental ecology very much in the same way as we think about fundamental physics. Now, the difference is, I think society says, ooh, physics is hard. And people say, ooh, ecology is tree hugging. And it's not, because both are fundamentally trying to understand the underpinnings of our natural world. And there's real value in that, right? There's real value in our advancement. If we think back in history, right, the people, we used to think the world was flat.
Some people still do.
Some people still do, right? But it wasn't commercialized research that taught us that the world was round, right? And yet that has had all these impacts on the way that we as a species function, right? And I think it's important that we always remember that just because there isn't a direct money-making opportunity doesn't mean that fundamental science isn't going to have value soon or not soon, and that's okay. That's still how society advances and how we move forward.
I mean, a great example of that is from the COVID pandemic, where our colleagues in the Doherty had been working for years on how to grow viruses in culture. That comes to fruition when a brand new virus emerges from China. They can grow it in culture.
That's right.
And then they can send that virus around the world. Now, they could have monetized that. They could have charged for every single sample they put out. Right. But they didn't, and that was the right answer.
That's
because it was morally wrong.
Yeah.
And I really think that's an important consideration. It would have been utterly morally wrong not to just send that virus out around the world so the whole world could start to research this thing.
Yeah, absolutely. And I suppose that brings us to another question, and that's about funding of research and how our government views science and their role in funding it. And I think with this sort of this growing feeling that impact is commercialization, increasingly our dollars are linked to how many industry partners you have, how many applications do you have. And I'd just like to hear a little bit about your thoughts on that. I'm certainly in my field there are other countries that invest a huge amount, like Germany invests a huge amount in thinking. And Australia doesn't have a history of doing that. And I wonder what your thoughts, the pros and cons.
Yeah, so having been here 4 years, I am now allowed to apply for citizenship. And we have just done the forms for that. So I think I am now probably allowed to start criticising.
You're a vice chancellor. You can criticize away.
I mean, seriously, the fact that this country, I think it's just under 1.7% of or 1.8% of GDP is spent on research budgets, compared with 2.5% in most of the rest of the world, and considerably more in some countries, is I think it's scandalous, actually. And I'm hoping that the new government will do something about that. But I mean, they're facing a pretty hard time because the economics is not great at the moment in different ways. But you know, I would still say that they should be spending that, filling that gap at least, and maybe more. The other thing I'd say is that this country needs to get with the program in terms of understanding the full economic costs of research properly. So this idea that the research grant funds your direct costs, and then there's all this kind of indirect cost stuff in the background that doesn't really matter, and you'll find the money somewhere. That's just garbage. Yeah. They are real costs of doing the research, and we should understand that. If government might not want to give a grant for 100% of that, but at least we understand what the real cost is, and we understand that they're only going to give us 80%. So then we can plan for filling the other 20. Yeah. You know, and we sort of do that anyway, but it's ad hoc. Yeah. So getting that sorted is very important. And I coming to another question, really, I think putting money into helping to translate research is really good and really important, I have to say. And that's why we've partnered up with Tanara Ventures to set up the Tin Alley Venture Fund, which has $100 million, maybe it's going to be more, which everybody in the room is entitled to apply for. And the Genesis Fund as well, which is the pre-seed, 15 million. Please, if anyone wants to do something in that field, just get with the program, as I said earlier, and talk to Ken Jefford, and it's a great opportunity. It really is. So I think that's really great. But I don't think that I don't think that all, certainly, and I don't think the majority even of funding should be tied with industry necessarily. I think we should be clear about funding the basic research, the discovery research that drives the entire system. Yeah.
And I think another sort of common thread with science and art is actually that our society seems to have a sort of a societal attitude that if you do something you love and are interested in, you don't really need to get paid for it. You should just do it out of the kindness of your heart. And on the one hand, universities are in this same boat, right? It's like we are this social venture that is supposed to be for the good of society, but increasingly our government is like, so we want to control you, but we also don't feel like we want to give you very much money because that's not worthwhile. Yeah. So I think we're at a bit of a crossroads in this country about our attitudes about the value of science and the monetary value in supporting the people who do it. That's a little hard to fix. Like, what should we do? Should we, should the government have more funding schemes? Like some of our funding schemes are not great at the moment. What do you think? What do you think the government could do to, if they decided we're going to triple the funding for science, what should they do with it?
Just pay us all 3 times a. But I spent most of my career being a career scientist. I'm paid very well now, as everybody knows. It's public information. But for most of those decades, I have been not paid very well at all. So I understand. I think scientists should be paid a lot more than they're paid, because they should be valued for the contribution they make to the society that we're in.
Yeah.
However, the problem comes that scientists will put up with being paid less than they deserve, because, as you say, we still want to do the science. So there's some form of weird market force thing going on there, which is hard to crack.
Yeah.
And while we continue to do that, I mean, with all due respect, let's say a lawyer, right, isn't going to get out of bed unless they pay them the fee that they charge, right? But we do. Yeah. So, I don't know what I'm waffling here, because I don't know what the answer is to that question.
No,
I really
it's a hard
don't.
question, I think.
And I don't know what your answer is, Margie.
I don't have one. That's why I asked you. I was told I could give you all the hard questions.
But there is, there are things that individuals can do. I mean, if they do have a good idea, commercialisation often does lead to a bit of extra money and that sort of stuff. But that's not an answer. I
think we are doing what we can, right? But I think there's a lot of lobbying of the government required to change attitudes. Definitely,
and it's not. I mean, I think an even bigger piece of the action isn't so much the salary, but it's the career path.
Well, this is I was going to change direction again a little bit, and a concern I have about this sort of culture, I call it the culture of poverty in academia. It's worse in the US, where it's almost like a macho thing. Like how much can you work for how little you get paid, which is a very unhealthy
And I was in the lab
attitude.
for 25 hours yesterday.
That's right. Well, I was in there for 26. But, our young people are entering science, and I think it's increasingly a less desirable pathway because expectations have changed about, which I think is a positive thing, right? We are having, I think young people want to do science, but they want a career pathway. They want a reasonable career pathway. And if anything, our career pathways are getting less secure and less desirable. And to me, this is one of our biggest challenges as scientists, of how to bring the next generation along and to support them in joining and becoming the next generation of scientists in a society that seems to be increasingly devaluing the work.
I think I just add to that that isn't a new problem. I did my PhD in the early 80s. Yeah. At the end of my PhD, I had no clue what I was going to do for a job. Yeah. I got lucky. And got a job.
You might be good at your job too.
I don't know if that maybe. But I got lucky with the job, and then in my second postdoc in Oxford, I was in the final year of that funding and beginning to. I'd taken on a mortgage by then. I was beginning to get really worried, and then the job cropped up, and I got it. So etc. And getting tenure. In my early 30s, it was really fantastic. Yeah, really lucky. Maybe deserving. I don't know, but there were lots of other deserving people who didn't get that. So so it goes. So I think there's been that luck of the draw thing forever in our world. Yeah, and I think part of that is because no matter how much we might like it not to be the case, a very large number of people who come through and do PhDs have always and still will not wind up eventually pursuing a scientific career in academia, because the pyramid is actually, too sharp. Yeah. And that's a resource-driven thing. It's inevitable, actually, in some sense. So, at the very least, we should be helping people coming into science understand that, understand that they've got to work really hard, be really good at the job, and also get lucky, right? It's no disgrace if you don't get the job, because you might have just been unlucky. Yeah. But then you can take all of the knowledge, education and skills that you've learned in that pathway and move them over into doing something slightly different. Yeah. And helping our young people understand that the alternative career paths that are available and how they might contribute in those ways and get a good life and a good career, I think is incredibly important.
I completely agree, and I think we're getting better at conveying to our young scientists that scientific skills are actually highly transferable. Yep. There's also different, you don't have to be in a university to be a scientist. Yep. And I think historically we didn't do a very good job of that. My supervisor certainly gave me the impression if you didn't get a professor job, you were a failure. And we need to stop doing that, and I think we have stopped doing that to some extent. But I also think there is this sort of hurdle of learning to become a scientific thinker, right? And it's almost it's just not surprising that people feel like you need to go into a particular pathway to effectively use that, you know. But I always think a funny story is, as an ecologist, I used to think my only transferable skill was putting fence posts in. I was like pretty good at manual labor. It never occurred to me that I could also run an organization, that I could also, you know, think deeply about all sorts of problems. And I think it's more of those sort of those skills and confidence in yourself as a scientific thinker, and the value of scientific thinking across our society, that's probably important for us to focus on in the future in helping our younger generation become our scientific community of the future.
Yeah, I totally agree with that. And you know, I think there are lots of schemes and stuff happening around that, but maybe not enough. Well, certainly not enough, actually. But I also think that anybody amongst our group here, or more generally in the university, thinks that there is a magic answer to this is mistaken.
Yeah.
There is no magic bullet here. There's just a range of things we're going to have to work on to try and improve the situation for everybody.
Yeah.
Actually.
Absolutely.
Yeah. You asked me about funding. What do you think about funding? No, seriously.
Well, I completely agree that I think there's an overemphasis on. Well, I suppose the way I would put it is the government is sticking their nose in things they shouldn't.
Yep.
In sense of seem to feel they get to decide what topics are worthy to study, even though they don't, by and large, have any scientific background at all. And I think that's where the problem is. I mean, that and the total amount. So I would like to see that, you know, I think the ARC is going through a rough patch. But I think it is inherently the kind of funding agency that we need, in which there is money available for the science to dictate what the most important questions are out there, instead of saying we only care about it if it has something to do with human health. Because that's just so narrow. And we are a small country, and so there's an argument that in such a small country we can't do everything well. But we also have aspirations. You know, the one that comes up is ScoMo used to say he wanted to have like an aerospace engineering industry in this country. But we're not really training the kind of thinkers that you need to be a cutting-edge aerospace engineering hotspot, right? And so, you know, I had friends in the U.S. calling me, and they're saying, "Oh, we're going to move to Adelaide because they're hiring all these people in aerospace engineering," because they were trained at Stanford and Harvard. So unless we're willing to invest in educating people at that level here, all these industries and these new sort of scientific-driven fields are always going to result in us bringing people from the outside. And to me, that's because we're under-investing in the acquisition of knowledge and thinking. And it's the creativity that drives these industries to new heights and sort of the cutting edge, right? Instead of, let's view university education in science as get a trade. Like get in, get out, and get your trade and move on. That's just not how the cutting edge science in the world is done.
Yeah, I agree with that. But I think I just modify, from my perspective, what you were saying there, Margie, in that as a foreigner who's come to the country, as are you, incidentally.
I'm aware.
It's not a bad thing that a country like this, which is an immigrant country,
Yeah.
Can attract the best talent from around the world.
Oh, absolutely.
I think that's a really good thing, actually. And if you start to build an industry around imported talent, of course, we should then also layer in homegrown talent into that as well.
Exactly.
So maybe that's the kickstart that's required, but then eventually...
But then we need a system that allows us to self-sustain.
Exactly right.
Yeah.
Yeah.
I think that's a good place to end. We've been given the signal we're done, but I just, to end up, I would just say there's lots of other Science Festival activities going on. You'll all have these little cards with QR codes on the table. Today, there's a lot of activities that happen to be around chemistry. There's a master class in exciton chemistry. So I encourage you all to have a look at the schedule for the Science Festival and get involved as much as you can. Thank you very much.